the clock somewhere there. I'm Ben, a research scientist here at Yale, based, 200 feet that way in this building. And I spent almost half my life as a microbiologist in applied science, developing solutions for antimicrobial resistant infections in humans. But today I'll talk about a little adjacent to that field, and maybe I'm doing the wrong one. The big one, of course. And that would be disease outbreaks in seafood. And so as the human population's growing, the demand for clean protein sources like seafood is growing along with it, if not more rapidly. And to meet that demand, aquaculture has really accelerated and now produces 57% of seafood consumed every year. And as we develop this agriculture, we need to really be mindful of the consequences of it. So take Ecuador, for example, which is the world's top exporter of shrimp. And they're a major provider to North America and Europe. And in the last 30 years, they've lost 70% of their mangroves. These carbon sequestering mangroves have been cleared to make way for more shrimp farms to keep up with demand. And as that demand increases, they're clearing the forests, and disease outbreaks are a major hurdle to producing more shrimp. They result in chemical discharge into water, disease transmission to coastal wildlife, and they spread antimicrobial resistant bacteria. One disease in particular is caused by a bacteria, Vibrio, and it drives 40 to 50% losses every production cycle. There are 3.5 cycles per year. And farmers spend 10% of their revenue on chemicals to try and reduce losses, but including the chemicals, they still have 40% losses. And this is where our solution comes in, which are bacteriophage. And they're the viruses of bacteria, and I've spent my life really studying these guys. Their life cycle is super simple. They're just in the environment. They bind bacteria, replicate within them, burst them, and each individual particle goes on to continue the cycle. But we're not just dumping random phages into ponds. We develop and characterize phages so that they infect only virulent bacteria. So in a population of bacteria, only a fraction of those will be able to cause disease. Our phage specifically target virulence factors on these bacteria so that when the phage kill all the bacteria, all the virulent ones, it's a success. And if the bacteria evolve resistance, which they often do, they're unable to cause disease. So that's our approach, and we believe we've done this in humans, human infections, 100 at least, and in lab studies, millions. And we believe pretty conservatively we can reduce mortality of shrimp in these farms by 50%, which will mean increased harvest for farmers, more shrimp and larger shrimp. We just came back from Ecuador a couple weeks ago where we met with some farmers, and they spend $8,000 a pond per year on disease prevention. That's already unsuccessful, so we think we can tap into that. So globally, there's a pretty decent TAM, and I'm running low on time. But our operation model is pretty simple. Basically, farmers will send us water samples and money, and we'll send them back, hopefully, we'll send them back a tailored phage cocktail and a microbiome report. How that works in practice is they're paying us and sending us samples that will help us expand our library and protect our intellectual property. And we've made a lot of traction in Ecuador. I've met with the government, a few of the ministries, and they were super excited by phage and wrote it into the National Development Plan. I have close collaborators at the university where they're receiving samples from farmers and isolating bacteria and phages already. We've got a few farmers interested in a field trial, and we just started one 2 weeks ago. So I hope to produce some exciting results from that. So this didn't render correctly, but I'm leading the team on the research side, and we have this amazing co-founder, Joanna, who is an experienced leader in global expertise in circular economy, B Corp, and she's going to make sure we keep our social and environmental mission. We have collaborators in Ecuador, Josue and Justin, who are amazing. Our next steps are going to be public benefit corporation, and we'd love to talk to people around here that have experience in any of these. And here's the team that has really advised us and helped out. And the prize would be life-changing for Josue, our Ecuadorian partner. If we get this, it'll support him to be able to continue doing the work and put a little bit less sweat into this and more time off for him.
Thank you very much.
Yeah.
Questions?
Ben, my understanding is that phage therapy is pretty strain specific. How difficult is it to continuously mash the phage cocktails to the evolving bacterial populations that you guys are going to be dealing with?
Yeah, so it depends really, but we have a pretty decent sized library and we're targeting virulence factors. So we're basically isolating phages that are more or less independent of the strain and more focused on the aspects of it that can cause disease. So we can deploy a virulence factor targeting phage for Vibrio parahemolyticus, for example, and that will just basically, more or less independent of strain, be able to select against disease-causing ability. So it is a problem, but it can be done very rapidly, 10 hours.
Great. And how stable is it in the aquaculture environment?
So far, very. Because we isolate phages from the environment in aquaculture, but we've tested them in the lab for stability, and so they have months at the very least in our current formulation. But as we're doing lyophilization, it'll be, it'll outlive all of us. So, yeah.
Super helpful presentation. Thank you. I'm curious about your side of the economics of the business. So, the cost that it takes to customize these treatments and the revenue that you're able to generate from each customer.
Yeah. So on the research side, we're basically doing a lot of the research to characterize them so we can determine orders, and so this will eat a lot of the initial cost. But then once we have that established, the lab techs in Ecuador here can quickly test sensitivity, and they'll have a predefined algorithm for what phages to deploy. So it can be done really inexpensively because phages can be produced cheaper than antibiotics, which are